Hello there, and welcome to our last lesson of grade 10 chemistry. This lesson is going to focus on acids and bases and their reaction together, which is neutralization. So the example I've chosen here is a piece of fish. I don't know how many of you have ever prepared fish, but depending on the fish, sometimes it has a strong flavor that not everybody likes because it's a little bit bitter. And that bitterness comes from a bit of basic molecule presence in the meat. And what you can do in order to make that more palatable is add a little lemon juice, which is acidic. It's got all that citric acid in there. So when you add the acid to the base, what you end up producing is something that's more neutral, which people will usually enjoy the taste of better. So there you go, a little bit of neutralization right in your food. So let's begin. Alrighty, step one, the acids. So we want to be able to identify acids, and you can't always put them in your mouth. The ones you can put in your mouth that are edible will all have a sour flavor, and you can identify those pretty quickly, right? If you ever like get a little vinegar, you know it has that sour taste. Acids are molecules that make hydrogen ions when you dissolve them. So all of them are going to be aqueous, meaning that they're all going to be dissolved in water. And there are three basic types. The first type is going to be our binary acids, and those have two elements. And the first one is always hydrogen, so it's always hydrogen plus something else, right? So hydrochloric acid is a classic one. We use it a lot in the labs. It's also the acidic part of gastric juice in your stomach. And it is just an H and a Cl in water. So AQ means in water. So all of your binary acids are going to have the same naming system. They're all going to have hydro at the beginning and then ic acid at the end, and the part in between depends on the other element that's being bonded with the hydrogen. So here's another one that's hydrogen and bromine. So this one's going to be hydrobromic acid. So that one's pretty straightforward. The second type of acids are called oxyacids. Those are the ones with the polyatomic ions that you learned about. So polyatomic ions. And so it's always going to be one of those, 7 that we've gotten used to. There are, of course, other ones, but we're just going to stick with those ones because we're familiar with them. So sulfuric acid is going to be from sulfate. There's SO4. And whatever the charge is, that's the number of hydrogens you're going to put with it. So sulfate has a charge of -2, so you're going to put 2 hydrogens with it. And then the little AQ, you've got yourself your acid. This one here is nitrate, right, with a hydrogen. So that will become nitric acid. So no hydro, but that same ic acid thing at the end. Now the last one group here are your organic acids. Organic acids all have this component of the molecule that has CO, 2 O's, and an H. And if you see the molecule drawn out, it'll look like this. It'll have the C with a double bond O, and then an O to an H. And you put your lone pairs in there and so forth. You'll see a lot more of those later on in sciences if you can keep going. Lots of those in biology. And more of those in chemistry as we go ahead. But for grade 10, the only one you need to really be familiar with is good old vinegar, which is acetic acid, and it's just a very simple one. It's got a carbon with 3 hydrogens, and then that C double bond O, OH thing on the end. So that is acetic acid, which is the main component that makes vinegar acidic, right? I think it's usually, if you look at the jug, it's about a 7% solution of acetic acid. Okay, so there you go. That's your clues for recognizing acids. You got 1 of 3 types. Well, let's move on. The bases that we're going to deal with are a lot simpler. Aside from the fish, there's not a whole lot of very strong basic stuff in food. Hopefully you're not eating things that are very basic. They don't taste very good. They're quite bitter, the ones that are edible. And I wouldn't be drinking any of these. This is some liquid plumber I found around the house, and it's good at breaking up oily guck in your pipes. And do not drink that, right? You can see damage it can cause there. This was another one, household ammonia. This is more for like cleaning glass. This is a little more concentrated solution that you can buy and then just mix it up to make like glass cleaning solution. But one thing they have in common is they all have this hydroxide component to them, right? And so you can keep an eye out for this and you'll know you have a base. So sodium hydroxide is NaOH, ammonium hydroxide is NH4OH. Basically keep an eye out for the OHs, and of course it only works when it's in water. Now, in order to compare the concentration of hydrogen ions or hydroxide ions in an acid or base, we're going to use what's called the pH scale. So the pH scale is related to the concentration of hydrogen ions, and you're probably familiar with the idea that at the center of the pH scale is this number 7, which corresponds to neutral or pure water. Then on this low end of the scale, you've got all of your acids, and they have lots of hydrogen ions in them. So you can see the concentration of hydrogen ions increasing here. And then at the upper end of the scale, we've got our bases. And they have a higher concentration of hydroxide ions. And right in the middle here, you got the place where there's an equal concentration of both. So the equal concentration of both the hydrogen ion and the hydroxide ion. And wouldn't you know it, an H with an OH makes water, right? H2O. Now the pH scale is a little different than other scales that you're likely used to in science. It's not a linear scale. It's not like on a thermometer where the difference between 1 degree and 2 degrees is the same as the difference between 3 degrees and 4 degrees. This is what's called a logarithmic scale, which means each number on the scale is a power of 10 greater or less than the one before. And so if you start at 7 here and you want to make something down to a pH of 6, you're going to have to increase the amount of hydrogen ion by 10 times. This is 10 times more hydrogen ions than 7 does. And then if you want to go to 5, then it's 10 times again. And so if you want to go from 7 to 5, that's going to be 10 times 10, which is 100 times more concentrated when it comes to the hydrogen ions. So here's a couple questions to help sort this out with you. It says, how much higher is the concentration of pH 3, so this guy, than one in pH 5, this guy? And so you can go 1, 2 steps, and each step is 10 times, so that's 10 times 10, which is 100 times. So you would say 100 times more or higher concentration. And then we're going to go from, it says how much lower is the concentration of pH 12 than pH 8. So if we're going this way, you can see the concentration of hydrogen ion is going down. And so we're going to go 1, 2, 3, 4 spots. And so basically add a 0 for each increment there. So 1, 2, 3, 4. So it's 10,000 times less concentrated than a pH of 8. All right, there you go, logarithmic scale. Other places you might have heard of this is the Richter scale that's used to measure earthquakes. Works the same way. Each number on the scale is tenfold the last one. Okay, now you know how to identify your acids, how to identify bases, and how the pH scale works to compare them. Now we're going to mix them, and that's called a neutralization reaction. And there's quite a few places where this plays a part in everyday life. Tooth decay is the result of acids that are produced by little bacteria that live on your teeth and feed on the foods that are left over when you eat something. So you want to get rid of the acids that are on your teeth by adding something that's slightly basic in the toothpaste. And so a little bit of base in the toothpaste will neutralize the acids that are produced by those bacteria, and you get to a condition in your mouth that is lowers the chances of you getting tooth decay. Many insect bites and stings are acidic as well, so bite equals acidic. the venom of many of like little ants or bee stings have chemical in there that's acidic, probably one of those organic acids with the COOH. And what you can do is you can add some of this afterbite stuff. It's the itch eraser, and it will react with that acid venom because it is basic. I think the kids version has baking soda in it, and the adult one has ammonia, which is a little stronger. Another place, which I thought was kind of neat, is when you're washing your hair. Now, cleaners, as you've seen, are mostly bases, right? So your shampoo is slightly basic. But if you just use the shampoo, it leaves your hair kind of dry at the end. And so what you usually do is complement that with some conditioner, which usually is slightly acidic, will neutralize any of the leftover base that might be there from use of the shampoo. You get back to something that's more neutral and your hair is more manageable and smooth. So those are pretty cool, eh? Combination of acid and base to get the neutralization. Alrighty, anytime you react an acid with a base, you are going to have the same products, or at least the same category of products. So you're going to need a base, of course. In this case, it's going to be sodium hydroxide, and then you're going to react that with an acid, and then you're going to end up with some ionic compound that is called a salt, and you're also going to end up with water. Now the salt here can be variable. It doesn't have to be NaCl, which is table salt. Any ionic compound can be deemed a salt if it's the product of an acid and a base. Now here is a urgent message, and you can imagine this is in wartime. And so what does this message say? Well, it says that the base is under assault. Yeah, that's a good one. All right. Okay, so let's apply that here. We know that one of our products is always going to be water. So we'll put that in here. And then let's see what's our salt going to be. Well, it's going to be the sodium with this sulfate. So it's going to be Na2SO4. And that'll be aqueous as well, but you don't have to worry about that. And then we need to balance it. So we've got, we need 2 NAs, so we're going to need a 2 here. Maybe I need a different color. I'll put 2 there. And that'll give us 2 H's with 2 OH's, which means 2 waters. And I think that's balanced. All right, second one here. You can put the water down first, because you know it's going to be water. And then we've got carbonate this time with aluminum. So we're going to do with aluminum. The carbonate has a charge of 2. Aluminum has a charge of 3, so that'll be your salt for this guy. I don't think that one's soluble, but that's just my own memory. You don't have to worry about that. This will definitely be a liquid, and let's balance this out. We need 2 aluminum, so we'll put a 2 up here. We need 3 carbonates, we'll put 3 here. We have 6 hydroxides and 6 hydrogens. That makes 6 waters. So for this one, I always look at the total number of the pieces that go into making the waters. So this is 6 OHs, and this is 6 H's. And you remember that an OH and an H means that you have a water molecule, right? So if you got 6 OHs and 6 H's, that means 6 waters, right? All right, moving on. Alrighty, so to finish off, we're going to look at how we can tell the difference between acid and base and whether or not something has been neutralized. So acids and bases are solutions that are usually clear and colorless, right? Can't see if there's anything dissolved in the water. And so what you need is a chemical that will change color to tell you whether something is acidic or basic. So the classic ones that we use in high school are litmus paper, which is a fungus, I believe, that changes color. And so they have these little papers that they've impregnated with this fungal extract, and it'll be red in an acid, and it'll be blue in a base. And so if you take one strip and put it into the other one, it'll change color when the other is present. Another one that's a liquid is called phenolphthalein, or I don't know if you really pronounce this pH in the middle. You can try saying it's phenolphthalein. Phenolphthalein. Usually most people just skip that other pH there. Anyway, so phenolphthalein is neat because it makes this nice hot pink purple color when it's in a base, and when it's an acid or when it's neutral, it is clear and colorless. So those are two common acid-base indicators that are often used in high school, but we have some other options too. The other options are that you can make your own. You can use stuff from around your house and see that it changes color in an acid and base as well. One thing you could do, if you like tea, which I do because I am a little bit British, there is some people who like to put a little bit of lemon in their tea. And you might notice when you add lemon to the tea that it'll change color. And that's because some of the leaves in the tea, the chemicals that they release are indicators, and they change color when they're in the presence of an acid like the lemon. Or you can go all out and find something that's colored and boil it up and see if it changes color. Classic one is red cabbage. So if you take a red cabbage or purple cabbage and you boil a chunk of it, you end up with this solution that's purple. It'll be a different color in an acid than it is in the base. Turmeric powder, you can see here I put a little turmeric into some water, then I added a little bit of vinegar, and you can see it's a lighter color after I added the vinegar. So that one's kind of subtle. It goes from like an orange to yellow, which isn't a huge change. The other one I made when our hibiscus tree was giving off a lot of flowers is I collected a bunch of them and threw them in a pot, boiled those up. Actually made a very nice tea if you put a little bit of sugar in it. It was very good. But it's also a great indicator. In the acid, it goes this really bright cherry red, and in a base, it goes this really dark purple. So it was a big contrast for that one. All right, so there's some fun you can have at home to see some of the differences between acids and bases using an indicator. Alrighty, it's been a pleasure. We'll talk to you soon.